Hi, in this video we are going to talk about writing base cases in recursion. Many times when we are given a problem and we wish to write a recursive solution for this problem, we can guess the recursive solution, like these are the subproblems we are going to call and this is how we are going to get their results and use the subproblem results to solve the overall problem. But it becomes difficult sometimes to write the base cases, how to write proper base cases so that everything is handled and we do not get Stack Overflow error. In this video, I am going to consider these two problems. The first problem is finding factorial of a number and our input number n is greater than or equal to 0. The second problem is finding nth Fibonacci number, and in this problem also n is greater than or equal to 0. Now please pause this video and try to write down recursive solutions for both the problems with proper base cases. Let us first consider the factorial problem and write down the recursive code for this. One thing we can easily guess is factorial of n can be recursively computed as n into factorial of n minus 1. So let's write down this part. We return n into factorial of n minus 1. Now please pause this video and think of writing the base cases. What do we write as a base case so we do not get any error in this problem? No Stack Overflow exception in Java or segmentation fault in C++. Our base cases are those cases, those inputs for which we cannot break the problem further into smaller subproblems. If we see the recursion tree for factorial 2, we call for factorial 1, then call for factorial 0, and after 0 we cannot break it further. If we see for factorial 3, we come to factorial 2, come to factorial 1, then call for factorial 0, and after that we cannot break it further. So 0 is the smallest possible value after which you do not break it further. Also, every recursive call ends up calling 0, right? Because whatever you begin with, it's going to call with smaller value, smaller value, smaller value, and then it's going to ultimately call for 0, right? So we write the base case here as 0. If n is 0, then we return 1. Now imagine that somebody writes wrong base case here. If somebody writes n equal to 1 here, what will happen when the test case is there with n equal to 0? So if you write the base case, wrong base case here as n equal to 1, right? That's a wrong base case. And what will happen in this wrong base case? If somebody passes 0, you will call for factorial 0, which is going to call for factorial minus 1 because it's not going to fall into this base case, right? It's going to call for factorial minus 1, which is going to call for factorial minus 2, and so on. It's never going to terminate. And in C++, you will get segmentation fault when you run this code. And in Java, you will get Stack Overflow exception when you run this code because it's going to take a lot of memory for recursion call stack and it's going to terminate with exception or error. Let us now talk about nth Fibonacci problem. We can easily guess nth Fibonacci number can be recursively computed as sum of n minus 1th Fibonacci number and n minus 2th Fibonacci number, right? So we can guess this part that we are going to return fib of n minus 1 plus fib of n minus 2. Now what do we write as base case? What all cases we handle in this particular problem? Please pause this video and try to write down appropriate base cases for this problem. We again need to remember the same thing. For base cases, we need to handle those inputs for which we cannot further break the problem into smaller subproblems. Let's see some example recursive inputs. When we have Fibonacci 2, we call for Fibonacci 1 and we call for Fibonacci 0. When we have Fibonacci 3, we call for Fibonacci 2, which calls for Fibonacci 1 and Fibonacci 0. And Fibonacci 3, after calling for Fibonacci 2, calls for Fibonacci 1. If you draw recursion tree for bigger problems like Fibonacci 4 is first going to call Fibonacci 3, then it's going to call Fibonacci 2. right? So we have handled the higher recursive calls also. 4 is going to call 3, 2. 5 is going to call 4, 3. So all those are handled if we handle these two simple cases. Now, what are the cases where we cannot further break the problem? Do we handle everything if we just write n equal to 0 as a base case? Please think of a case which will not work when you write 0 as a base case only. The case is n equal to 1. If you simply write n equal to 0 as a base case, what will happen if somebody calls for n equal to 1 or these recursive calls for n equal to 1? 1 is going to make a recursive call for 0 and minus 1, right? And minus 1 is not a valid input. Our input is greater than or equal to 0. So we need to handle two base cases here. We need to handle n equal to 0 and we need to handle n equal to 1, right? So we write our base case as if n is equal to 0, then return 0. If n is equal to 1, then return 1. Although we can combine these two also. We can say that if n is smaller than equal to 1, then return n. That's a shortcut for writing these two base cases. But we need to handle n equal to 0 and n equal to 1 both. Otherwise, we'll be in problem. Let us see what happens when we write n equal to 0, return 0 as the only base case, right? It's a wrong code. What happens here is when you call for Fibonacci 1, it calls for Fibonacci 0 and Fibonacci 0 finishes immediately because we have a base case to handle 0. But this Fibonacci 1 is going to make one more call for Fibonacci minus 1, right? Because we do not handle 1 explicitly. When minus 1 is called, it's going to call for Fibonacci minus 2 and then Fibonacci minus 3. And Fibonacci minus 2 is going to call for Fibonacci minus 3 and minus 4. And it will go on. So you will get a Stack Overflow exception in Java and segmentation fault in C++.